Hello and welcome. In today's video, we'll be talking about ACI endpoint learning and forwarding. In this video, we'll be discussing how the ACI learn the endpoint, how it populate its table, and also how it's do the forwarding. Before we discuss that, we just need to review how the traditional network used to do the forwarding. For the switching side, we have our legacy switch here connected. Usually, the switch populate the MAC address table, which contain all the MAC address information along with the physical connected interface. Like here I will say MAC address A connected to ether 1/1. How usually it used to populate the MAC address table and know all the information for the connected endpoint in order to create a closed circuit and end-to-end communication within the switch, usually by sending a flood. Whenever the switch receive unknown MAC address, it will flood the traffic throughout all the connected interface, hoping that the concerned destination will respond with its MAC address, hence populating the MAC address table with the destination and establish the connectivity. Okay. That's when it's come to layer 2. Of course, for layer 3, if we're using the MAC address, if we're using a multi-layer switch, there is also ARB table. And by knowing the ARB table and the MAC address table, you can have all the information required in terms of layer 2 and layer 3. There is also the routing table, which we used in the forwarding. You can say that those three tables are the main tables that we are relying on the traditional network. In Cisco ACI, things got changed. In Cisco ACI, it had replaced the MAC address table with something called the endpoint table. Now, the endpoint table, it's similar to the MAC address table, but there is two major changes here. The first change is the endpoint table can populate MAC address table along with IP address table, hence playing a role of a combined MAC address as well as ARB table into one unified endpoint table here. Okay. ARB table are required, but required for external connectivity outside the fabric. However, inside the fabric, you don't need an ARB table nor a MAC address table because endpoint table is doing the job. Of course, the routing table will remain the same. The route forwarding, route lookup will remain the same, similar to the traditional network. The thing, the point here is that we no longer need a MAC address table or ARB table in the environment. We have now an endpoint table. Okay, and you can examine the endpoint table by logging to the leaf itself, SSH to leaf, SSH to the leaf itself, and type show endpoint table. It will give you all the necessary information. Now with single command, you can check the IP address, MAC address, and the connected interface. You have also a routing table, so therefore you can also use the show IP route to check the routing information. Okay, now what type of endpoint I have or the leaf can learn within the fabric? The leaf can learn two types of endpoint. The locally connected endpoint, and that's as the name implies, it's a local connected endpoint which is physically and directly attached to my leaf. Okay, now what the information the leaf will get to know? Of course, the leaf will get to know the MAC address, and if I have the unicast routing feature enabled within the bridge domain, I will obtain the ARB the ARP information or the IP address information for this particular endpoint, plus the exit interface or the connected interface. Okay. Another type of endpoint that will be the remote endpoint. The remote endpoint simply it's an endpoint which is connected to a different leaf and learn via VXLAN. Okay. So VXLAN is propagating this information through the TIP information tunnel endpoint protocol. Okay, and it will be visible to my output when I type show endpoint. Okay, that is not connected to directly interface. It will be connected via tunnel. Okay, so this is how the leaf learn about the endpoint. Either it's local or remote endpoint. Okay, what if my leaf does not know where is exactly the location of the endpoint? Of the endpoint itself. It will consult the spine, and we have mentioned earlier that the spine is using a protocol called the COOP, the Council of Oracle protocol. The main role of the Council of Oracle protocol is to build up a database for the entire endpoint that connecting to the fabric on different leaves, hence having a full visibility over the endpoint, and also make sure that all the spine within the fabric keeping a consistent database as well. In that fashion, the spine will be acting as like a big database containing all the endpoint information. In order to make all this information available for the leaves which does not know the destination information, destination endpoint information. Okay. How we will introduce a new connected endpoint to the leaf. Now, bear in mind one thing. Usually, the learning process or the MAC address table population process happen on a traditional network by learning the destination MAC address, whereas the Cisco ACI or the endpoint table learning processing happen by learning the source MAC address. So the lookup here happens, I should say, based on the source information rather than the destination information. Usually, because you're relying for forwarding and the destination lookup, you're relying heavily on the spine itself. So the main objective, or I should say, the learning or the endpoint population process happen on the leaf level by learning the source information rather than the destination information. So how the leaf is going to learn all the endpoint information simply by the data plane. Let's assume, for example, I have one endpoint appear, and this endpoint start to send routed traffic to outside world. Simply, when the traffic flows go through the leaf interface, it will write down all the information. Either it's a layer 3 information, IP address, I mean, or layer 2, which is the MAC address. Another way of doing that is the ARP request. Let's assume that I have this device connected. Whenever this device trigger an ARP request or DHCP, okay, so the spine itself will trigger, the endpoint will start to trigger either DHCP request or ARP request, and those traffic flows the leaf can take advantage of and learn the source information and populate it in the MAC address table. In the endpoint table. What if I have a silent host? Also, there's some sort of gratitude ARP that can be generated from the leaf itself in order to activate if you have a silent host. When I say silent host here, I'm referring to a server which is sitting idle in the environment and not sending any traffic. However, it shows that it physically up. So in some cases, yes, the leaf can generate a gratitude ARP itself, acting as some kind of refresher to this silent host and make in order to make it start to interact as a network, hence coming to know, hence sending a traffic, which helping the leaves to understand more about the source information and populate it in the endpoint table. Okay, so I have this endpoint attached in the network. Okay, send the traffic. This is how the endpoint table looks. Okay, I have the endpoint A with the MAC address and the IP address along with the exit interface. Okay, and there also one cool feature here. If you have virtual machine VMM integration with Cisco ACI, you can also know about the host and the host name within the virtual environment. Okay, once the leaf will get to know all the endpoint information, it will start send all this information to the spine. Okay, using a message called zero queue messaging. The zero queue messaging responsibility in the Council of Protocol is to populate the spine with all the host information coming from all the leaves. Okay, so by the way, all the leaves, they are populated the spine simultaneously. Whenever a leaf detects that there is a connected spine, the spine will always receive as zero queue messaging or endpoint information whenever an endpoint comes up. Okay, and also there is some hash messaging that happen between the it's called the distributed hash, I believe, this message between the spines to keep the kube database of the endpoint consistent. Okay, and this process happen instantly once the leaf learn or detect that there is there is an active host or an host became alive on the environment. And now we'll discuss the forwarding scenario after we fully understand, after we have understanding about regarding the endpoint and how we can populate this endpoint and how the leaf can learn information about the endpoint. Now let us discuss the forwarding, how the forwarding happen inside the Cisco ACI. Actually, there are 4 different scenarios. Okay. The first one, if I have the source leaf knows where is the destination, and it turns out that the destination resides on the same physical leaf. Okay. Second scenario, if my source leaf knows where is the destination, and it turns out that this destination resides on another leaf. Okay. The third scenario, if my source leaf does not know where is the location of my destination, and it will consult the kube protocol or the spine here. Okay. The first scenario, if I have my source leaf does not know where is the destination, and it will be used the legacy way of doing flood. And why do I need to do flood here? We'll explain that on the next slides. Now, let us discuss the first scenario, which is my endpoint, my leaf, okay, or my connection between 2 endpoints that connected to same physical leaf. What will be the traffic flow here? Okay, simply the request will reach the leaves. Okay, the traffic will be reaching the leaf. Okay, the leaf will inspect its endpoint table, and by the way, the endpoint table will be inspected either for layer 2 communication or layer 3 communication. Okay, and don't forget that we have mentioned that we have a pervasive gateway on all of our leaf switches. Okay, so what happened when I found when the local leaf discovered that the destination endpoint is connected to a local interface. simply it will forward the traffic with no issues. So you consult the endpoint table. Also, it's called the local station table. Okay, you consult the local station table. By the way, the endpoint table at the leaf, it's called the local station table. The endpoint table at the spine, okay, which of course populated by the COOP, it's called the global station table. So for local communication within the leaf, no need to consult the global station table. You can do it locally within the endpoint, within the local endpoint table. Okay. Now, second scenario would be if the destination is connected to a remote leaf. However, I know where is exactly the location of this remote leaf. What will happening is you send the traffic, okay? You know, we know, okay, no, so this is the source information of the endpoint, and now we try to send the traffic. You can see that will be my destination information. This is my source information coming from point A. That will be my destination information going to point B, okay? I know what is the IP address and the MAC address, and I also know the location, which is in VTIP 100.02. What happened is you need to encapsulate this traffic over VXLAN. By the way, VXLAN is the VXLAN is the a tunneling protocol similar to GRE tunnels, where you encapsulate the original payload and cover it with an outer header, as we will see in a moment now. Okay. Now, what will happen is there will be some sort of encapsulation where you will encapsulate the inner data here with an outer data, with an outer header. The outer header would have the destination IP address, the next hop VTIP here. So the VTIP here, it would be the IP address of the loopback of the destination leaf. Okay, and how this is how the payload will look like. All the green boxes here representing the original payload or the inner payload, which contain the source MAC address and the destination MAC address of the hosted themselves. Okay, what happened is when the traffic leaves the leaf, it will encapsulate it. It will provide two additional information. Okay, it will provide destination. It will provide source VTIP IP address. When I say VTIP here, I mean leaf, in order to be used by the VXLAN. So I will be sending a source VTIP IP address or leaf IP address, and I also will add destination VTIP. And VTIP, it's a tunnel interface, by the way, and I'll be based on the IP address. Okay, of course, since my fabric is up and running, I have ACI's information to advertise and exchange information about the VTIP information here, the VTIP IP addresses. We have also explained it's using a loopback IP address of the leaf itself. So you cover the original payload with source IP address of your VTIP and destination IP address of the remote tip. Okay, and of course there will be source MAC address and destination MAC address. And what will be the layer 2 information here? What will the VLAN I'll be using here? Of course, it will be VLAN 4, which allow the communication between the VLAN. What will be happening here is, like, I'll be sending this traffic to the spine. The spine will inspect. It will do normal routing here, since I have here source IP address from the source VTIP, destination IP address. And once it reach the destination leaf, it will decapsulate the outer information, okay, and check this information against its local station and send it to the local machine. So you have to, in the local endpoint, you have to understand that one of the main functionality of the overlay here is to route all the outer information. Actually, it's like a simple tunneling that happens within the overlay. Okay, so that is the action been taken if you have a destination which you know where its location, however, it's on a remote leaf. Our third scenario here, which is the forwarding using the spine proxy feature, if my destination is unknown into the environment. Okay, so what that means, we try to send a traffic. The leaf try to send a traffic for unknown destination. However, under the bridge domain settings here, under policy general, I have the hardware proxy feature enabled, which is called the spine proxy. Okay, there is two options. Either I can go with flood or the hardware or the spine proxy. In our scenario here, we'll be discussing the spine proxy, the destination lookup using the spine proxy or the hardware proxy feature enabled. Now, let's have a look at what exactly going to happen when the endpoint start to send the traffic. Okay, what will happen is the leaf itself, it will start to look up at the local station table, and it will find that there is a missing information here for the destination. After that, it will do the similar encapsulation process where it will maintain or keep the original IP header. It will add the source IP address, sorry, source VTIP address, okay, which is the IP address of the local leaf. In the destination here, it will add something called anycast IP address. The anycast IP address, it's sort of multicast IP address, referring to all the spines or pointing to all the spines that participating on this in this multicasting group. So what I'm trying to say here, that I'm sending anycast message for all the spine, hoping that one of the active spine will respond to me. So I'm sending anycast. It's kind of like SOS service or help a help request or interruption here, that I need an information. Okay, so the traffic will go to the spine, check the original information regarding the endpoint, and once it discovers that there is a connected endpoint, what will happen, it will change the destination VTIP information instead of using the anycast into the destination leaf. Okay, and after this decapsulation process, it will reroute the traffic to to the destination leaf, which is VTIP 102, after modifying and rectifying the outer destination VTIP information here to make it point to the intended destination leaf. Okay, and this is what happened on the proxy spine scenario. Next scenario will be the flood scenario. Now, a question here. Why do I need to do a flood option anyway? You see, there was under the bridge domain, there used to be two options, the hardware proxy, spine proxy, and we have discussed that. And there is also the flood option. Why do I need to do the flooding anyway? You see, in order to, you see, there is one traffic behavior which is related to the hardware proxy spine feature. If the kube does not know the location of the endpoint, it will drop the traffic. So the endpoint should always be connected to the fabric and always be updated on the global station table located at the spine. Okay, so assuming that the spine does not know the location of the endpoint. Okay, so what the spine is, how the spine is going to behave? Simply, it will drop the traffic. Okay, then what is the use case of having a flood, and why the spine will not be able to learn a certain endpoint information? Simply, if you have, you see, you have to understand the global station table act inside the fabric. Let's assume that I have my ACI fabric connected to external unknown layer 2 switch for instance, which contain also a MAC address table. Now, this external switch, it does not participate in a co-process anyway. Okay, it's still using the legacy flooding process on the traditional network. So one of the rectification for this issue is to activate the bridge domain to have a flood behavior. Okay, in order to do the flood, by activating the flood, you're just bypassing the COPE consultation, and simply you flood a traffic to search for the destination. However, it will be using a multicast IP address within the fabric, as we have agreed. When it's once it comes out to the external switch, yes, of course, it will be using the regular broadcast, I think. So the point I'm trying to make here is we need to use flood option enable if we have the bridge domain connected to the external world. This is one of the external layer 2 external switch, and this is one of the use case of having the flood. Okay. Now, how the flood behavior works. You have your local station also. You've seen that the endpoint send the traffic with unknown destination. The leaf itself will try to understand, will try to look up for the destination. After it find out that the destination is missing on the local in the local information local station table, it will check against the bridge domain information. Okay, and if the bridge domain have the flood checkbox enabled, simply what it will do, it will flood the traffic out of the interface. Okay, but this flood is using a multicast. And why I'm using a multicast here, if you will see, this is the inner header, of course. That is my outer header, and that is this is my source VTIP information, the loopback IP address of this leaf. And for the destination here, I'm sending something called a group IP outer. Okay, the group IP outer, if you recall, during the initial stages, initial setup of the fabric, we have to define a group IP outer. Actually, the group IP outer is like a range of IP acting as a listener, and each bridge domain that each leaves that participate on a bridge domain should have a a multicast group IP address assigned to it for this flooding situation. So the flooding will not hit all the leaves. The traffic will hit only the leaves that participating in this bridge domain that contain the group IP information. So they're actively listening. They are with the IGMB, okay, listening to this particular IP address. And of course, each bridge domain will listen to a certain group IP address. Okay, assuming that will be 255.1.1.5 for bridge domain 156. So let's assuming that this endpoint is associated with this bridge domain, so it will send the traffic to this multicast group IP address. Hence, all the leaves that participating in this bridge domain will accept and will take the traffic and will start to do the lookup inside their local station. Okay, and once it find it, it will start to respond back to the leaf. Now, the ARB handling. Okay, by the way, you can enforce the Cisco ACI to do always do ARB flooding, despite if you have also spine proxy enabled, or you can rely on the local station table to do the ARB resolution for you. Okay, now how are we going to check the endpoint connectivity? On our previous lab setup, we have completely configured the logical contract. We have assigned the interfaces. We also have applied the contract. Now we want to make sure that our bridge domain is operational. There is a couple of ways to do so. First is you hover over, jump over the bridge domain tab here. Okay, you go under operation, you go under client endpoint, and you will see all the endpoint information appearing on the tab below. It will give you, if you have if it's layer 2, it will show you only MAC address. If it's layer 3, it will show you the MAC address along with the IP address associated to. One other thing is, if you want to do with the CLI, and by the way, the leaf and spine can be accessed via CLI, okay, but you can only type show configuration, or you can only display configuration. You will not be able to do any configuration. You can only display the configuration here. So another way of confirming my endpoint, simply by logging to a certain leaf and type show endpoint. Okay, you can type show endpoint in general. You can specify the VRF along with the bridge domain, and that will display to you all the VRFs with all the information it's connected with all this information within this particular loop, that leaf that you already connected at. Okay, and you can see here the interface. Some of the endpoint are connected to the interface 101. Some of them are connected to tunnel 8. So tunnel 8 mean here that it's a remote host. Ethernet 101 mean it's locally connected to my domain. Another way of examining the local endpoint connection by SSHing to the leaf itself, and you type show endpoint, you provided the IP address or the MAC address. It will show you here the VLAN information, the MAC address along with the IP address. You can tell here that this endpoint bridge domain have unified, have layer 3 enabled, and it's have an IP address. And you can see it's here R mean it's a low, sorry, it here, sorry, it mean there is L here. L mean it's local, and you can see the exit interface as well. Now, the remote endpoint examination, okay, will happen. You will not be able to see an exit interface. If you will type the same command, you will not be able to see an exit interface. Instead, you will be seeing a tunnel interface referring to the tip IP address or the next hop leaf that contain the this host information, either its MAC address or IP address. In this slide, we'll be discussing how the layer 2 forwarding happened inside the bridge domain itself. You see, there are multiple type of VLAN communication that happen within the bridge domain. As we have agreed earlier, the bridge domain is not a normal VLAN. It is a layer 2 construct. And of course, this layer 2 construct is built upon the layer 3 overlay. So it behaves different from the regular Ethernet VLANs. Okay. Now, inside the bridge domain, there are multiple VLAN information. There is something called the protocol independent VLAN. The protocol independent VLAN, it's a VLAN associated to the bridge domain. It can be unique at each leaf. Like for instance, here I have some bridge domain. It's called bridge domain 1. Okay, this bridge domain 1 extended across leaf 1 and leaf 2. However, the protocol independent VLAN is different. So it's not unified. It can be locally significant on each and every leaf. The purpose of the protocol independent VLAN is to do the external VLAN mapping. You have to understand, when we do a trunking with our external communication, with our external interface, and here I'm referring external interface such as our server or bare metal server or our WAN environment or switch environment. Those considered for Cisco ACI as an external connectivity that require external VLAN tagging. This external VLAN tagging is the same traditional .1q tagging that you're using in the traditional environment. However, when it's go inside the Cisco ACI, it's need to be mapped with the protocol independent VLAN. Each external VLAN, it have some sort of mapping. Those mapping happen within the switch, within the leaf switch with something called the protocol independent VLAN, okay? Also, if you have VXLAN, you have also, it needs also to be mapped with the protocol independent VLAN, which is, as we mentioned, unique and local to the bridge domain itself, okay? Another piece of information also that the when the traffic leaves, we have mentioned that leaves the when the traffic leaves my leaf, it re-encapsulate the payload and add an outer header. We have discussed the destination tip and source tip in the previous slide. Also, one piece of information that that needs to be added to the payload is the VXLAN information. And what does the VXLAN information contain? It contains a field called VNID. The VNID contains all the necessary information that need to be traversing from one leaf into another. For instance, it contains a unique VRF ID, as well as unique bridge domain ID, and EBG and external VLAN information. So all of this information, when they are leaving the one leaf into another, they need to be written down on the VNID, okay? And of course, you need to have a unified VRF ID as well as unified bridge ID in order to be able to communicate and reach out to the proper, I would say, leave and destination on the remote LAN. So one of the main also the main functionality of the VXLAN information, especially the VNID header, is to carry on, okay, all the internal leaf information such as the bridge domain, the VRF, the EBG, as well as the external VLAN information, and send it to the destination. So when the destination do the lookup, it can accommodate this information into the proper bridge domain, VRF, EBG, and so on. And by the way, when you type show endpoint here, okay, this will show you, when you type show endpoint here, also show VLAN, it will give you two pieces of information that you need to understand. The VLAN that it's showing here, this is not the external VLAN that communicate to the outside world using the Ethernet 101. Actually, this is the protocol in the protocol independent VLAN that are associated to a certain bridge domain that communicate inside my ACI. The next column, I will see the VLAN 5 here. The VLAN 5 here, okay, as it shows here, this is the access encapsulated VLAN. This is the VLAN that communicate to the external world. This is how the normal 802.1 tagging happens between the Cisco ACI and the external connected interface. It could be switch, router, or server. Last but not least, we'll discuss the bounce entry feature. What is the bounce entry feature? The bounce entry feature is the feature action been taken inside the Cisco ACI to allow the mobility of the endpoint, seamless mobility of endpoint without, I would say, flushing the local endpoint table and the global endpoint table as well. Assuming that I have an endpoint, okay, it's connected to leaf B. What will happen once I connect this endpoint? Leaf A, as we agreed, will send ZQ message, okay, to the COOP from the local station to the global station table of this spine to update the information that currently endpoint P is connected to leaf 2. Now, let us assume the endpoint had been shifted from leaf 2 to leaf B. What will happen, from leaf 2 to leaf 3, what will be happening is leaf 3 will send a ZQ message to the spine telling them that I have a new update. Endpoint B no longer reside at leaf 2. It currently reside on leaf 3. And here are the new information. What will be happening next is the spine leaf will update leaf 2 with the new information here. That will update the leaf 2 information that you have to understand that you are my bounce entry, meaning that you no longer have this MAC address B. So whenever someone asks you reach to the endpoint B, you simply bounce the traffic directly to leaf 3. Okay. So in that way, we can guarantee that we don't need no need to do reflushing of our kube database. Okay. With that being mentioned, I hope that been informative to you, and thank you for viewing.